Today's problem is to find the bitwise AND of a range of numbers. Here you are given a range. For example, range is 10 to 15. Then you have to find a result which will be the bitwise AND of 10, 11, 12, 13, 14 and 15. We are not allowed to skip any number. And one simple approach you can take is that create a result variable which will be the same as the first variable, that is first element of the range, and you iterate through all the elements of the range and keep doing AND with the result, and finally you return the result. But that can be an very inefficient solution if the range is very large. Here you had a range of 5-6 numbers, but it can be very big, and it's not wise to iterate through the complete range to find this bitwise AND. The binary representation of numbers occur in some regular patterns. So here in this video, we will try to understand the pattern and exploit that pattern in order to find the bitwise AND of that range of numbers in very, very quick time. So let's first understand the pattern, then we will look at the solution. So if you see the pattern here, I have listed the binary representation of numbers from 1 to 15. You see that here it's 1. So this yellow line denotes when there is a increase in number of bits. So for 1 you can represent in 0 or 1, both you can represent in 1 bits. I should have written 0 also here with the representation of 0. Then for 2 to 3 you will need 2 bits, and for 4 to 7 3 bits are required. Obviously you can use more bits and add zeros in the end. And from 8 to 15 4 bits are required, and you see this number keeps on doubling. 1, 2, 4, 8. Next will be 16 to 31, and that will be a range of 16 numbers where 5 bits will be required. And you also notice that the most significant bit is 1 for all of these, because if it becomes 0, you can effectively represent in one less bit. So now let's see that these occur in pattern. So if you look at this range, you will see this pattern, and if you see this range, you will see that this and this patterns are repeated. For example, you see 1011. This is 1011. And if you dig further into this, you see 0 and 1 are here. So 0 and 1. And now let's look at this bigger range. So if you look at the bottom half, you see 111, then 110, then 101, then 100. So this, if you ignore the most significant bit, this 3 bits are same as these 3. And now you make this bit 0, then you look at these 2 cross 2, then it will be same as these 2 cross 2. So these occur in pattern. Let me draw a graph of this. So let's take one of the range. Let's say we are doing this range from 8 to 15. So first is 8, last is 15. So let's say this denotes 8, 15, and this value denotes 1 and 0. So everything, this is most significant bit, that is the leftmost bit. For 8 to 15, it's all 1. Now let's see the second most significant bit. So we had seen at leftmost bit. Now I am looking at, let's call it 4th bit. Now we will look at 3rd bit. So you will notice that first half is 0, next half is 1. So we can draw it as first half 0, next half 1. Still it denotes the same range, 8 to 15, but this was the graph of 4th bit. This is the graph of 3rd bit. Now let's dig one level deeper. That is, we go to 3rd bit, or 2nd bit rather. I'm counting bits from right. Now let's see the 2nd bit. So now we are looking at second bit. So second bit, first two are 0. First two are 0. And this is 0 to 4, first four numbers. So half of that will be 0, half of that will be 1. And now we reach here. So we reach here, again first two will be 0, then 1. So again half is 0 and half is 1. Now let's look at first bit. So these sizes are 2 to length, 2 length, 2 length, 2 length, 2 length. Total 8. Here it's double, 4, 4. Here it's all 8. And you look at first bit, even half of that will be 0. Then half 1, then 0, 1, 0, 1, 0, 1. So it's flipping after every number. So this width is 1. So for every alternate number, it flips. In the second digit, for every alternate 2 digits, it flips. For third bit, every alternate 4 bits, 4 numbers, it flips. Next bit, for every alternate 8 bits, it will flip. Let's say you were asked to draw for range 16 to 31. What you would have done? This first 8 would be 0. Then it will be 1. This fourth bit. And fifth bit will be all 1. 1. So this pattern will repeat everywhere. So now the thing that I wanted to you to borrow from this is that no matter what is the range, if you look at a smaller range, if a smaller range is constant from here to here, if you look at any higher range, that is, you look at any bit which is more significant than this bit, then that will also be constant in that range. So if you look from this range, and let me write the actual numbers here. So this is 8, and this is till 11 it's 0, from 12 it's 1. I should have drawn a slight slope here, or we can exclude one of these. So till 11 this is 0, from 12 it's 1. Then 8, 9 is here, and 10, 11 is here. And 12, 13 is here, 14, 15 is here. So you pick any range in any of the bits. Let's say I pick in second bit. So 12 to 13 is constant. You look at the value in any higher bit. 12 to 13 is here also constant. There is no fluctuation. Let's go one level up. Here also it's constant. Similarly, we pick 8 to 11 in third bit. So we are not looking below it. We are looking only above it. So if I look at 8 to 11 in all the higher bits, we will see that here also it's constant. Similarly, if I look at first bit from here to here, it's constant. In fact, it's 1. So there is no meaning of constant here. So we can start from here. Any range you pick in any bit, for all the higher bits, that range will remain constant. You will not see a fluctuation in higher level, and in lower level you have this kind of thing. So here you see a fluctuation, and in lower level that is constant. So this will not happen. Fluctuation will increase in lower levels, and to be concise, we will divide every higher level into 2 parts and make first half 0, next half 1. Similarly, here to here it's constant. So we break it into 2 halves. First half is 0, next half is 1. And again I break this into 2 parts. First half is 0, next is 1. Now I cannot break since this is 1 length. So the idea here will be that we will try to find the first bit from left which is common in that range, because everything to the left will be common. So if in some range, in some bit range, it's constant, then it's constant in all the higher levels also. So here, what is the meaning of AND? So if we do AND of two numbers, let's say 10101, and second number is, let's say 10100. So what will be the AND of this? This is 10, so it will be 0, 0, 0, 0, 1, 0, 1. So any bit is 0, it becomes 0. That is true for more than two numbers. If we have 1010, next is 1110, next is, let's look at this range itself, 5 to 7. So 5 to 7 we are calculating. So this has a 0 here, so complete thing will be 0. Now let's look at second bit. Again 10 is here, so everything will be 0. Now let's look at third bit. Everything is 1, so it becomes 1. So the AND of, or we will call it AND of range 5 to 7 is 100. Or not 100, it's binary representation 100, which is equal to 4. And how do we calculate it? We find what is the bits which are common. So if it's B1, B2, B3, B4, and for this second range, this is M, and the second range is N, and it's let's write in capital B1, B2, B3, B4. This is N, this is M, but we don't know numbers between them. So let's say B2 is common. B2 is same for all the numbers from M to N. So B2 is constant. B2 may be second bit, maybe third bit. So let's say it's third bit and it's constant for that range. Let's say our number is from M and N lies here. And the third bit is constant for this range. Then that means all the higher bits will also be constant in that range. So now we know that if B2 is same as this capital B2, then B1 will also be same as capital B1, and all the higher bits will be same in that range M to N. And we have picked, this is the first bit from the right, which is common. This is not common. This is not common. So it is bound that these are different, and different means 0 and 1. Only two values are allowed. So if any value here becomes 0, it will become 0. So let me write the result. This will become 0. This will become 0. Because this will become only 1 if all the bits are 1. And then this will be same as B2 and this will be same as B1. So the AND of all the numbers from M to N is B1, B2, 0, 0. And this is the first bit which is same for all the numbers in this range. There are other numbers in this range. This is the range from M to N. And why I have taken here all the bits constant, same, because let's take a case where M lies here. Let's say 6 is M. And N lies here. So 6 is represented using 3 bits. N is represented using 4 bits. So whenever that is the case, that number of bits in M is not the same as number of bits in N, then the result will be 0. And why is that? Because whenever there is a bit jump, so here is the first bit jump, same here. So let's take here. So whenever there is a bit jump, the first number will be 1 followed by all zeros. And N lies somewhere here. 1 then some bits. There are some other numbers. And we had said that there is a bit difference. So M is, let's say, here. So it will have bits from B1, B2, B3, B4. This is M. And there are some other 4 bits numbers here. And this fifth bit is 0 in M because it's represented by 4 bits. So if you see here, these all 4 bits are 0 here. So no matter what are the other values in this range, this 0 will make everything here 0. This 0 will make everything here 0. This also 0 and this also 0. And everything to the left of this B1 is 0 in M. So this entire thing becomes 0. And this 0 will make everything 0 for this range, and these zeros will make everything in this range. So whenever there is a bit difference, the result will be 0. So if the bit difference is not there, then we will find the first bit that is common to all the numbers in that range. Then it's guaranteed that all the higher bits will also be common, and all the lower values will be 0 because there is some value which is different, and different means some are 0, some are 1. So these will be 0, and this will be the result. So how can we find that? We will see if m is equal to n. So if m is equal to n, there is just one number in that range, so we return that number. But if m is not equal to n, then m will be less than n. So if m is less than n, then it's guaranteed that least significant bit will be different for some numbers, because least significant bit flips after every one number. It's never same for two consecutive numbers. So we have to make it 0. So what we will do, we will shift everything to the right by one step. So m becomes 0, b1, b2, b3, and b4 goes away. Similarly 0, b1, b2, b3. Again we will see these are not equal because we had claimed that this is the first bit from where onwards everything is common. So again these will not be equal, so we will again right shift it. So what will happen? One more 0 here and this will be gone. So these are m and n now. So if b2 and b2 were common, small b2 and capital B2, then these are same and all the higher bits were same. So these m and m become equal. So we will do this right shift till both m and n become equal. And once they're equal, in order to get the result from here, to get this result, what we need to do, we right shifted here by 2 steps. We keep track of that count. Now we left shift by 2 steps. So what will happen? It will become b1, b2, 0, 0. This n. Similarly, m will become b1, b2, 0, 0. So after left shifting it, we can return the result. So let's write code for this. First we will write in C++. Then we will update it for Java and Python. So this shifts keep track of how many right shifts we have made so that we can do that many left shifts in the end. And when they become equal, we will return. And that's all. So the explanation was very big because the idea there was that you understand the pattern in the numbers, especially if they are occurring in sequence. And the code is very simple for this case. So let's try. So it works for this case. Let's try some more cases. Some big number, let's say 5 to 12. And here it should give 0 because here there is a bit increase here. 5 is represented in 3 bits, 12 is represented in 4 bits. So there will be no bit which will be common to all of these. So it's 0, you see. And now I make it 15 and this, let's make it in the same range, 17 and 28. And our answer is same as expected. So let's go ahead and submit it. And our solution was accepted. Now let's write the same thing in Java. I don't think here any change is required. All these operators are valid in Java as well. And it works for this case as well. So let's submit. And the Java solution is also accepted. Finally, we will write it in Python 3. And here also left and right shifts are valid. And semicolons also I will leave it because these don't make any difference here. Invalid syntax. Okay, only change is here. Shifts plus equal to 1. So it works in Python as well. So we can go ahead and submit it. And the Python solution is also accepted. So I hope you enjoyed this problem, especially the explanation part, how there is a pattern in the bits of the numbers. You have to keep this in mind. If a range is constant for some bit here, so if for a range of numbers from here to here, this bit is constant, then for the same range of numbers, all the higher bits will be constant and all the lower bits will have some fluctuation, and all the lower bits will become 0 when we do and all the higher bits including the constant bit will remain as it is. So that is the result.